write a program with different modules or many modules, or we can say many sub-procedures. So we will start the program like normal by including win32.inc. We will have a data segment here and our code segment here. Within our code segment we will have the main procedure. The last line of the main procedure will be exit, and the last command would be exit, and the last line of the main procedure would be main NP. And we also know that the last line of the program is always end main. Now if we have sub procedures, they can be declared either after the main procedure or before the main procedure, as you like. So let's say if we declare them over here. So let's say we have two sub procedures, one by the name of input procedure. So this is the start of the input procedure. All sub procedure will always return with a return statement, and the last line of any sub procedure would be its name and NP, which signifies the end of this procedure. Similarly, we can have another sub procedure here by the name of, let's say, calc sum or calculate sum. So this is the name of the procedure with the procedure directive. Again, it exits or returns with the return statement, and then the last line of this sub procedure would be calc sum and p. Now let's say if we are calling these sub procedures from within our main procedure, which is how it usually is, then we will have simple call statements in our main procedure. So we have call input and call calc sum. Now if we have any any variables in the data segment, for example an array by the name of array, which is of type byte, let's say it has 10 elements and initialized to 0, then this array or this variable is sort of a global variable which is available or which is visible throughout the program in all sub procedures as well as the main procedure. Now in the sub procedures, we know that when we are calling using the call statement to call any sub procedure, for example call input over here, then what this statement does is the call statement basically pushes the value of the or the address of the instruction following this call statement, which is this one in this case, onto the stack. So it saves the value of this instruction on the stack, or the address of this instruction on the stack, and reloads the instruction pointer with the address of the first instruction of the input procedure, and the control transfers to this procedure. Later, when it reaches the return statement, the value which is being pointed to by the stack pointer register, which is always pointing towards the top of the stack, is reloaded into the instruction pointer, and the control is again transferred to the main procedure, and in this case it will be transferred here. Now this sub procedure, this array is visible throughout this program. So for example, if I would like to reduce the number of instructions in my program, I can initialize some registers over here by saying move ECX, 10, similarly move ESI, offset array, so that I do not have to initialize these registers before or within each of these procedures. So now what I will do is, inside the input procedure, if I push these two registers onto the stack by saying push ECX and push ESI, and similarly pop them in the reverse order by saying pop ESI and pop ECX, and let's say my main or the main instructions of my input procedure are over here. So here are my main my instructions for the program for this procedure. Then when this procedure returns, the values of the registers ECX and ESI will be preserved, even though if they were changed during this procedure. So now I don't have to reinitialize these registers before I call the calc sum procedure, and these registers would still be holding the original values which were initialized here.